Madam President and managers. We just want to take a few minutes to present a brief summary of the 2024 Do-It-Yourself and Citizen-Assisted Tributary Monitoring Programs. Victoria D'Amico is here as well. She'll be presenting several of the slides. In 2024, we had two areas of investigation. For the Do-It-Yourself monitoring, we studied the direct drainages to Comfort Lake and also the County Line Subwatershed, which is part of the Sunrise River watershed. And for the Citizen-Assisted Tributary Program, we looked at all three basins of Forest Lake once again. These are the same study areas that we had in 2023. We use the same technology as previous years, the HAK DR300 pocket colorimeter that detects orthophosphate, and we targeted precipitation events greater than 0.75 inches from May to September of this year, past year. Before we take a look at the results, I just wanted to note the climate conditions in 2024. 2024 is considered an above average precipitation year. We're close to record years for precipitation from spring all the way through summer. It rivaled at times the precipitation we saw in 2019, which is the wettest year to date. As such, we had many monitoring opportunities this past year. We were able to collect 481 samples in 2024, which is approximately 4 times greater than the number that we collected in 2023. And it offered a good opportunity to see how our watershed responds to a wetter hydraulic regime. All right, moving on to results. This is the Comfort Lake direct drainage area. Map of the different locations, and then the color of the dot there indicates the average orthophosphate reading there. You can see we've got several in that brighter red. We did add 2 new sites in 2024 around the Little Comfort area, which is LC1 and LC2. We had 13 sampling events that took place in 2024, with a total of 102 samples collected and analyzed. The majority of the samples did show elevated orthophosphate levels, as we did see throughout the majority of the 2024 sites for DIY and CAT. Of the 15 sites, CD1 and CD9 had notably higher orthophosphate levels than all other sites, and Site 6, an old stormwater pond, was also a site of interest. Sites CD1 and CD9 are directly associated with roadway runoff. This is likely the source of sediments that is responsible for the elevated orthophosphate levels at these locations. CD9 is a stormwater manhole with noted deposits of sediments present, and CD1 is a private gravel driveway or road with poorly drained ditches causing water to pool, and we had elevated levels from that area as well. It's likely that samples collected from these locations were taken from semi-standing or slack waters that tend to result in higher orthophosphate readings. More study in these areas is definitely warranted. CD6 is an area of greater interest. This is an old stormwater pond that receives water from the southern part of the East Comfort Drive drainage area. This site, this evaluation site, CD6, was expanded in 2024 to look at both the inlet and outlet of that pond to better evaluate the stormwater pond. DIY monitoring data indicates that water entering the pond is cleaner than the waters exiting the pond. This was verified by sending several of these samples to instrumental labs in Fridley to verify those results. We did contact the city of Wyoming. It is not part of their MS4 system, as the housing development predates the stormwater rules. And staff is planning to reach out to the landowner there with the intent of developing a future pond clean out at that location. Could potentially reduce the amount of nutrient coming in from that drainage area and improving water quality in Comfort Lake. Here's a box and whisker plot of that data that we, of those monitoring locations for Comfort Lake direct drainages. As a reminder, the box represents the interquartile range, or 25% on each side of the median. The line in the box is the median. The X is the mean, and the whiskers represent the lower and upper extremes or maximum values. Any circles or dots beyond the whiskers and indicate data outliers. So again, the majority of the samples or locations looked at here in the direct range to Comfort Lake did have elevated orthophosphate levels in 2024. You can see sites CD1 and CD9, those roadway associated areas having the highest values. And then you can see site 6, the old stormwater pond, where we've got higher orthophosphate concentrations at the outlet as compared to the water coming into the pond, indicating that that is a potential source of nutrient for Comfort Lake. Moving on to the county-lined subwatershed. This was identified in 2021 as part of the Sunrise River diagnostic. This area had elevated orthophosphate levels, and in order to pinpoint the source of the nutrient in the subshed, we added some additional sites to this drainage network and then we collected samples in 2022, 2023, and 2024. In 2024, we collected a total of 59 samples over 9 precipitation events. We saw elevated orthophosphate levels at each location, but highly elevated readings were found at sites CLD, CLE, and CLF. This is similar to what we've found in the past, and those sites are located in the blue oval there on the map. Here is that data presented as a box and whisker plot. You can see the 3 sites along Greenway Avenue, those ditched areas there where we saw the elevated readings. They're right along Greenway Lane and Greenway Avenue North. Both of these ditches are within close proximity of each other and follow a busy road that connects Highway 8 to North Shore Trail. It's likely that these roadways are a source of nutrient due to the heavy traffic or that these ditches themselves are now a source of nutrient as they have collected decades of nutrient inputs from the roadway. This data supports the importance of the street sweeping program that we have in the district and also points to a need for roadway ditch maintenance to reduce any of these loads that have accumulated in these ditched networks.
With the efforts of 3 staff members and 5 volunteers, the 2024 Forest Lake Subwatershed Citizen Assisted Tributary, or CAT, monitoring program monitored 23 sites across all 3 basins of Forest Lake. The program's 5 citizen volunteers and district staff collected a total of 306 samples across 30 rainfall events. Due to record amounts of rainfall in Minnesota, sites were sampled over 4 times as frequently in 2024 compared to 2023. Each site was sampled a minimum of 8 times and averaged 13 samples per site. One new site, FL2-8, south of Basin 2, was added in 2024, and 2 sites from 2023, formerly FL2-6 and FLB-2, were unable to be monitored due to access restrictions. Comparing the data from 2024 to 2023, the increase in rainfall created different trends depending on land use of the area draining to the site. Wetland-heavy areas saw an overall increase in phosphorus levels in 2024, while residential zones saw an overall reduction. It's theorized that larger, more frequent storms can flush out orthophosphate buildup that wetlands have sequestered from the surrounding area during dry periods. Meanwhile, less frequent storms may allow more time for phosphorus to build up on impervious surfaces before a rain event. This speaks to the importance of long-term monitoring to understand which management practices will be most effective long-term. It's important to note that the above analysis shows variability in orthophosphate release year to year and does not compare the overall orthophosphate levels of wetland-dense watersheds to residential-dominated watersheds. Of the 23 sampled sites, 86% had elevated phosphorus readings, and the 6 most elevated sites averaged over 1.0 milligrams per liter. Though the trend of elevated phosphorus levels is clear, additional monitoring is needed to narrow down which sites can be candidates for additional management. Site FL3-3 was sampled from the outlet of a wetland east of Basin 3 and was found to have the highest orthophosphate levels of all sites sampled at 1.95 milligrams per liter in 2024. However, in 2023, it was just above average compared to other CAT sites with an average orthophosphate reading of 0.89 milligrams per liter. Contrarily, FLB-1 was sampled from a pipe draining stormwater catch basins along residential streets. In 2024, it was found to have an average orthophosphate level of 0.76 milligrams per liter, just about average compared to other cat sites sampled. However, its average orthophosphate levels were the highest of all cat sites in 2023 at 1.51 milligrams per liter.
Thank you, Victoria. The duplicate water quality comparison study was picked back up in 2024 using samples from the lake hypolimnion monitoring effort, so some of our camp samples, bottom water samples there. We took those samples to instrumental lab as well as analyzed them with our DIY pocket colorimeter. In total, we had 107 samples that we analyzed this year and compared with a Wilcoxon signed ranks test. That test determined that there was a statistically significant difference between the two data sets. So not statistically significantly the same, but similar results between the two sets. However, there was quite a bit of variability within the data set of the DIY colorimeter. Despite this result, we conclude that the DIY hot colorimeter is still a useful screening tool in advance of a traditional diagnostic monitoring effort, or this technology could be used for ballpark nutrient concentrations throughout the district. So still a very useful tool, but definitely cannot replace any official commercial lab analysis of our water quality samples. In conclusion, 2024 was considered to be an above average precipitation year. This allowed for the collection of 481 total water quality samples and gave insight into the watershed response to a wet hydraulic regime. The 2024 water quality data indicated elevated orthophosphate levels throughout much of the district, associated with both roadways and wetland monitoring locations. We theorized that the numerous precipitation events in 2024 allowed for the transport or flushing of nutrients and sediments that had been stored on the landscape, whether that could be in roadway ditches or wetlands or uplands as well. These accumulations have been collected over the past two dry summers and are leading to the elevated results we see in 2024. These results verify the importance of enhanced street sweeping and point to the need for roadway ditch cleanouts and maintenance, and also the protection of and enhancement of neighborhood wetland habitats, which we consider to be the kidneys of the district, intercepting that stormwater and helping to purify those flows, those waters before entering into our major bodies of water. The 2024 monitoring effort also had two significant outcomes. First was the identification of a potential water quality improvement project for Comfort Lake. This would consist of the clean out of an old stormwater pond that drains directly into wetlands along Comfort Lake shoreline. Data indicates that the stormwater entering this pond was significantly cleaner than water exiting the pond, thus pointing to the pond as the source of nutrient. Staff will be working with the landowner to develop this potential project in future years. The second outcome is the conclusion that the hot colorimeter results are of statistically lesser quality than those from a commercial lab. This technology will continue to be used, but with the knowledge that it only gives ballpark orthophosphate concentrations. So our recommendations for this coming monitoring year are to repeat the DIY and CAT efforts. So looking at Comfort Lake direct drainages and the Forest Lake, all three basins of Forest Lake with the CAT program. And we feel that we've got enough data collected to discontinue the duplicate sample comparison study and the county line subwatershed monitoring efforts in this coming year, and just focusing on Comfort Lake and Forest Lake.
I'd like to take a moment to acknowledge our CAT volunteers who helped us collect a large data set, especially during evening and weekend storms. A huge thank you to Sue and Tom Konitzer, Tony Kuhn, Keith Coonley, and Kristen Stevens. Thank you very much.